Ladies and gentlemen, good afternoon. My lecture is on the urban heat island of Mountainous city, Mediterranean city with a desert frontier, the case of Jerusalem. Although the UHI is the most widely investigated phenomenon in applied climatology, UHI studies on cities in mountainous region are relatively uncommon. Cities in mountainous region in hot climate have a unique environmental characteristic with relatively cool temperature which create a good comfortable living condition. However, rapid urbanization followed by resulting of urban warming and climatic change have been to take a toll on the climatic condition of some, if not most, of these cities. Masson et al. In 2020 illustrated example of the UHI pattern in several geographic situations. Their review shows that the main mountainous cities that have been investigated are located on hill slope and valleys. Only one city located on a summit in the polar region have been investigated. They conclude that the study of mountainous cities may be an emerging topic for urban climate research in the years to come. Accordingly, the objective of our study is to contribute knowledge concerning the UHI phenomena in Mediterranean mountain cities, to explore the variation landscape variable they could potentially help explain the special variation of surface temperature in the context of landscape, topoclimate, and elevation, and to examine the synoptic condition on the mountain cities in various seasons at different time of the day, and to suggest appropriate urban design. The study area, the city of Jerusalem, is located in a mid-latitude in central Israel with a population of about 1 million people. The climate of Jerusalem is Mediterranean. One could see the location of Jerusalem, Mediterranean, with a desert frontier. The city is characterized by hot and dry summer with relatively stable weather condition and a mild, wet winter with stable episodes. The site selection of Jerusalem is as follows. The city located on a plateau, on a summit of the Judea mountain in the Mediterranean climate. A large forest can be seen west to the city, and at the east side of the city one can see the desert frontier. When we look at the topography map, one can see that the city is located on a ridge and on the summit. The methodological approach is integrative one, a local climatic zone classification, methodological observation of data collected from official meteorological stations, satellite images, and a finely comparison between all the various systems. So when we are looking at the local climatic zone of Jerusalem, one can see that the densely built area is located at the center of the city and in the east side of the city, while the western side is much more open built. The meteorological station were 7 meteorological stations that were investigated, 2 of them in the rural area, west to the city inside the Jerusalem forest, and 1 at Ma'ale Edomim, the town on the eastern slope, represent the desert climate conditions. Summer air temperature duration shows that the weather is relatively stable with a minor heat wave, and each day we have the same temperature pattern. When we analyze the urban heat island, one can see that during the day, the hottest place is the industrial area north of the city, which develop urban heat island of 3.5 degrees, and during the night, the city center is the hotspot of the city and develop heat island of 4.8 degrees. The orange line is, of course, the desert city at the eastern slopes. When we look at hourly temperature under heat wave, we still see the same pattern, but the intensity of the urban heat island is less pronounced. Examination of Jerusalem surface urban heat island shows that the eastern part is the city is much warmer than the western side that, as I mentioned before, it's open rise buildings with vegetation inside. During the winter, the weather changes on a daily basis and the UHI can develop only under dry weather events. One can see here differences between the city center and the rural area. When we focus our results on dry and clear days, one can see that the nighttime urban heat island is only 2.5 degrees and the daily urban heat island is 3 degrees. And again, the hotspot during the day is the industrial area and during the night, the city center. And again, looking at the surface urban heat island show the same phenomena. The eastern part of the city is hotter than the western side of the city. So actually, what is the intermediate insight? The summer UHI is more intensive than the winter one, which is opposite to all the theory that we are known and opposite to what Tim Oak taught us. And we see here completely different phenomena, and we try to explain why. So looking at the wind roses for a well-developed UHI on summer night, one can see that wind in all the station flowing from west to east, and we're talking about wind speed of 4 to 6 meters per hour. So why it's happened? We have to look at the typical summer synoptic system over Israel and the eastern Mediterranean basin. On the sea level, we can see a Persian trough over the region at sea level and barometric height at 500 millibar. Both create the same wind called Etesian wind, which flow most of the time all the summer season. So when we look at the cross section, we see that the wind is coming from the sea, climb up in the mountain, pass over the Jerusalem forest, penetrate into the city, and become hotter and warmer towards the east. What happened in the summer? What happened in the winter? In the winter, we will see quite different phenomena. During the night, on the western hill slope, the wind is easterly wind. And in the western slope, in the eastern slope, the wind is from the west. And wind speed is very low, up to 3 meters per second. And again, looking at the synoptic map, one can see high barometric pressure east to Israel, accompanied by high ridge at 500 millibar, or in another event, a Red Sea trough with low wind velocity, and again, high ridge in 500 millibar. This unique situation create the following. During the night, under calm condition, katabatic wind start to develop from the summit towards the plain or towards the Jordan Valley, and there is a descent of air that push the hot air from the city towards the edge, and then the katabatic winds start to develop. This, together with the barometric height pressure, moderate the effect of the UHI in Jerusalem. So the main findings are as follows. As opposed to cities located on a plateau, the development that develop an intensive UHI during winter night, the mountainous city of Jerusalem developed an intensive UHI during summer night. In general, the west part of the city, which is built-up area with open vegetated spaces, LCZ5, is cooler than the dense area in the eastern and the northern part of the city, which contain LCZ2 and 3. And the industrial area, LCZA, are the hotspot during the day, whereas the dense residential neighborhood, LCZ2 and 3, are the spots hot during the night. The city location on a summit induced the development of katabatic wind on winter nights, which can moderate the intensity of the UHI. And important note, it should be noted that the above findings are based on LST and rooftop meteorological station. It can be assumed that meteorological measurements at street level will reveal a much higher UHI. Thank you very much.
One question? Any questions?
Okay.
Move to the next.
All right.
Thank you. Our last but not least presentation is from Dr. Yatian Cheng, talking about lakes and cities.